Hello, welcome back. This is our second part of discussion, Home Worksheet 2, Atomic Structure. Under the first part discussion, we completed the 19 questions I have given in Home Worksheet 2. That is to develop the confidence in atomic spectrum, quantum numbers, write in electron configuration in these three areas. Now, today under part 2 discussions, then we are going to discuss past paper questions given from these sections. So you develop the confidence there, then now it is time to test your confidence. So since I gave this several weeks ago, maybe all of you have tried this paper, these questions, and then waiting for the answers and waiting to identify your mistakes. Then I'm going to discuss it. These questions are from 2008 to 2024. Let's see what type of questions they expect in the exam. Right, let's move to first question, A-level 2024. The orbital diagram in which both Aufbau principle and Hund's rule are violated. Aufbau principle, you know, it is something like this. Then when you fill the electron to atom, ground state atom or ion, first you check the orbital or sub-energy level, which has the lowest energy level. Then we put the electron to that. After completing that, only the electrons are added to a next available orbital or sub-energy levels. First we complete the sub-energy level with lowest energy, then only we go to the next available sub-energy level. That is Aufbau principle. Then we have to find out which one then violates Aufbau. What about the first one? After completing 2s, it goes to 2p, then no issue. What about second one? Without completing second 2s, they have moved to 2p. That is violation of Aufbau. Then you find the second one is a possible answer. For a third one, you know, after completing 2s goes to 2p, no issue. After fourth one, after completing 2p, then go to 2p, 2s, then go to 2p, no issue. But fifth one again, without completing 2s, they have moved to 2p, so it can't be according to Aufbau. So therefore, in second case, Aufbau violated. Fifth case also Aufbau violated. Therefore, then we have to find out which one then violates Hund's rule out of these two. But in the case of Hund's rule, you know the point. I mean, it is something filling electron into degenerate orbitals. So degenerate orbitals means the orbital with same energies. Here it is actually 2p. Then you know the rule actually. In the case of 2p, you know, then we can represent orbital using a box or a circle, doesn't matter. 2p1 should be like this, then 2p2, what do? We pair or fill the other with single with same orientation, then second option. Then what about in second question? Is this, then that is wrong because it is 2p3. If it is 2p3, it should be like this. You can't pair. First of all, you fill the orbitals with single electron with same orientation. But in 2p3, in second answer, without filling the electron to this, they have paired it. It can't be. And in second case, Aufbau is violated plus Hund's rule also violated. If you just check fifth one, Aufbau violated, but there is no problem in the case of Hund's rule. Once they complete it, then fourth electron goes and pair. Yes, that's no issue. So answer is 2. 2024. The first question, it is then answer 2. Again, there is another question in A-level 2024. In an atom, how many orbitals? How many orbitals? Not electrons. How many orbitals? How many orbitals can have the quantum numbers n equals 3, ml minus 1, and n equals 4, ml minus 1? Let's see. In an atom, how many orbitals can have the quantum numbers? This is again A-level 2024, second question. N equals 3, ml minus 1. So there is no condition for L. That means you can you can consider all the three possible L values for n equals 3. But in ml case, there is a condition. So if L is 0, ml 0. If L is 1, ml minus 1, 0 plus 1. If L2, it's minus 2 minus 1, 0 plus 1 plus 2. So what is one condition? N should be 3. That is satisfied. The other condition, ml minus 1, ml minus 1 here. Okay. There is another ml minus 1. N3 ml minus 1. N3 ml minus 1. Then how many orbitals are there? You know, ml gives number of orbital. Here there are two boxes, means there are two orbitals. First case, it's 2. But there is another. N equals 4, ml equals minus 1. N equals 4, ml is minus 1. Hurry. N equals 4. Then what are possible? 0, 1, 2, 3 possible. Up to n minus L minus 1. Up to n minus 1 is possible. In L0, ml0, this is minus 1, 0 plus 1. This is minus 2, minus 1, 0 plus 1 plus 2. And this is minus 3, minus 2, minus 1, 0 plus 1 plus 2 plus 3. Those are the possible ml values. Now, the condition n should be 4, hurry, but ml should be minus 1. Then here minus 1, n4 minus 1, n4 minus 1. This is also minus n4 minus 1. Then how many boxes are there? 3 boxes. Means 3 orbitals. Then here 2 orbital, here 3 orbital. Total 5 orbitals should be there. Then in level 2024, second question, then answer should be fourth one. In this case, answer should be fourth answer. Here, second answer. Next, we move to 2023, A-level 2023. So, let's see the question. From the list given below, they have given several electron transitions. Identify the emission lines in hydrogen spectrum that have the highest frequency and the lowest frequency respectively. Energy levels 1, 2, 3, 4. Yeah, then 4 energy levels involved. Then I just draw it like this roughly. These are the 4 energy levels. This is first one, second one, third one, fourth one. Remember, the gap between the first and second is very large compared to the gap between any other 2 energy levels. Sorry. 3 goes to 1. That is the first transition. 3 to 1 transition is there. 2 to 1 transition is there, right? Next, 3 to 2 transition is there. Right? Thereafter, 4 to 2 transition is there. Okay. Thereafter, 4 to 3 transition also there. Then out of these, they ask the frequency, highest frequency and lowest frequency. You know, then from the gaps, actually, what we can have the idea about the energies, not the frequencies. If you get a large gap, large energy released. If you have a small gap, then small energy released. But the question is about frequency. Then you need the relationship between energy and frequency. As you know, energy is directly proportional to the frequency. The largest gap, largest energy, then highest frequency. Smallest gap, smallest energy, and then smallest frequency. Right. Then they ask first largest, highest frequency. So which one is highest? This is where you get the largest energy gap, 3 to 1. N equals 3 to 1. That is the largest. Thereafter, they ask the lowest frequency. Lowest frequency, then smallest energy. Smallest energy means shortest gap. This is the gap. 4, 3 is the 1. 4 to 3 should be the next one. N equals 4, N equals 3. Then 3 to 1, 4 to 3. Very fine. 3 to 1, 4 to 3. That's in second answer. So here, the answer should be 2. Let's move to 2022, A-level 2022 question. What is that? Which of the following electronic transition belong to the visible region of the line spectrum of atomic? Then, you know, visible region, which series? Balmer series. If it is Balmer series, what is the common factor? All the transition should end up at second energy level. So therefore, wherever you find electron transition from 3 to 2, 4 to 2, 5 to 2, 6 to 2, then these things should lie within the visible region because those are Balmer series. Then 5 to 3 can't be. 4 to 2, yes. 1 to 2, no. Then the thing is this one. I mean, second answer 4 to 2. Second answer given 4 to 2, this one. Here what happened? Energy of the electron decreases. Means energy emitted. That is where you have the emission spectrum. They ask about belong to visible region of spectrum of atomic hydrogen. The energy emitted Then the energy emitted, this electromagnetic radiation then coming out of the tube. Once you pass that one through the diffracting grating, you have a line in the spectrum. That line is colored because the energy, frequency, wavelength, everything correspond to visible region. Right? But what about 1 to 2? I mean, there is transition from 1 to 2. Again, energy level, second energy level involves the transition end up at second energy level. But what about this one? I mean, emission, no absorption. This is absorption spectrum, because energy increases from 1 to 2 mean energy increases, energy of electron increases. Energy of electron increases mean it absorbs electromagnetic radiation, not emitted. Then once you pass this one through the prism, you have a line. That line represents energy absorbed. But that line then can't be colored. It is dark. But they ask which of the following electron transition belong to the visible region. Visible region belongs to visible mean there should be a colored one. Then emission spectrum they talk about. So in that particular case, then answer should be second one, 4 to 2. In fourth case, up to 1 mean Lyman. Fifth case, up to 1 mean Lyman. So it can't be. So it should be second answer. 2022, it should be second answer. No need to explain. Then in theories, we draw all the diagrams and I explain why gap decrease, what does this line represent, everything in detail. Right, here answer should be 2. Right, let's move to 2021. 2021. So it's about again quantum numbers and which of the following statement incorrect with regard to an orbital energy level of an atom with principal quantum number n equals 3? Incorrect, right? First one, there are 3 subshell. Actually, in the class, I explain an easy method to get it. If the atomic number n, principal quantum number, if the principal quantum number n, number of subshell is equal to n. Therefore, n equals 3, then subshell 3, correct. I don't explain this thing in detail because we discuss it. There are 9 orbitals. Then if the quantum number n, I gave the number of orbital given by n squared. So n is 3, 3 squared means 9. Second one is correct. Third, there can be maximum 18 electron. Then if the principal quantum number n, the number of maximum number of electrons in that can be 2n squared. So n squared 9 squared 18, 18 into 2. 9 squared pyramid. Then n equals 3, then 3 squared 9, 9 into 2, 18 electrons. So third one is correct. Fourth one, there can be maximum 10 electrons with angular momentum quantum number L equals 2. So if n is 3, L2, what is it? N3, L2, what is this? This is 3D. There are ml values. How many possible ml? There are 5. If there are 5 ml values, then each and every orbital can have 2. 2 into 5, there are 10. Yes, it is possible. Now, then first 4, correct mean it should be fifth one. There can be maximum 8 electrons with magnetic quantum number ml. Then not only 2, then I have to consider all the other. Just I take it like this because I took D first, then I go to 1. It is 3p. Then it is minus 1, 0, plus 1. Then I take 0. 3s, it is 3s. Then it should be 0. It is upside down. If it is 3, the possible value 0, 1, 2. But the question is ml. N is condition, then ml condition. Ml 0. Here, then ml 0, ml 0, ml 0. Then how many orbitals are there? Ml mean orbital. 3 boxes mean there are 3 orbitals. Then how many electrons are there? 3 into 2, there should be 6. But this says maximum 8 electron. Not possible. If n is 3, ml 0, maximum 6 electrons can have that combination. So therefore, fifth one is incorrect. That is the answer for this question. Next, 2020. This question is something like this. The number of electrons in manganese atom, atomic number given 25, that have quantum number L equals 0 and ml minus 1 respectively are. Then these are exam questions, right? Then you can have questions, but it's not then direct question. Like they don't ask the symbol like n equals 5, L equals 2. What is the symbol? 5D, like that. There is something else because this is a level exam. But still it is possible to answer if you have realized this real meaning of this quantum number, configuration, everything. Manganese 25 mean, first I write the configuration. It's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d10, or 3d10, 4s2, doesn't matter. Here, then again, when you write the configuration, it can't be condensed one because we need a complete one. We have to find out L equals 0, all the number of electrons. They ask electron, not the pairs. Yes. L equals 0 means what? L equals 0 means s orbital. Maybe n equals 1, but s, then there are 2. Maybe n equals 2, but L equals 0, s, then 2. Maybe n equals 3, but L should be 0, means 2 here. Maybe n equals 4, then 2. What about that? L equals 0, there are total 8 electrons. Not only that, there is another, and ml minus 1 respectively are. ml minus 1. So ml minus 1, where do you find ml minus 1? In the case of S, do you find ml minus 1? You can't have ml minus 1 in S. Why? Because then L equals 0, ml is 0 only. If L equals 1, ml minus 1, 0 plus 1. Then in the case of P, L equals 1 mean P. In the case of P, you can have ml minus 1. Not only that, if L is 2, it's D I'm talking about, then it can have minus 2, minus 1, 0, plus 1, plus 2. Then you see, here also minus 1 available, here also minus 1 available. Even in the case of F, minus 1 is available, but in the case of manganese, we don't have F. That's why I consider P and D only. S doesn't have, then P can have minus 1. ml minus 1 means, remember one orbital we consider, one P orbital here, one D orbital. One P orbital and one D orbital. Hurry. Then ml minus 1. Then P. Then if it is 2p6, it's completely filled. If it is completely filled, one P orbital, there can be maximum 2 electrons. You remember that? According to Aufbau principle, according to Hund's rule, according to Pauli exclusion principle, if you apply everything, you find a 2p6 completely filled, mean one orbital, one P orbital, there are only 2. Here also 2p6 completely filled, then one orbital, only 2. Then look at this one. I made mistake here. It's 25 mean 3d5. It's not zinc, manganese. 25 mean it's 3d5, 3d5. Then in the case of D, I told you ml is there, ml minus 1 is there, 1d orbital. D not completely filled. Then you have to be careful. If it is not completely filled, we have to be careful. We can't say it's 2 electron or something because we have to find it out. 3d5, you have 5d orbitals like this. How to fill it according to Aufbau? 1, 2, 3, 4, 5. Then ml minus 1 mean 1d orbital. In one, maybe it's this one, maybe it's this one. We don't know which one is minus 1. Then any of this, there is only one electron in 3d5. Can you understand it? Here there is only one electron. It's not 2 electron or something. So 2 plus 2 plus 1, it should be finally 5. Then 8 electrons and 5 electrons. 8 and 5, the answer should be third. Here the answer should be third. Got it? Let's move to 2019 question. This is about like this, the maximum number of electron pairs of an atom that are associated with principal quantum number n equals 3. Then you have to be careful. N equals 3, it's okay. Then I have given the equation, I mean simple method to get the number of electrons. It's 2n squared, there are 18, but there are 18 electrons. There are 18 electrons. I mean, there are 18 electrons, but the question is about the maximum number of electron pairs. How to get electron pairs? Then if there are 18, then it should be divided by 2, 9. Or in other words, you can take simply orbitals, number of orbitals. It is then 9 orbitals, means 9 electron pairs. Because in an orbital, you can have maximum then 2 electrons, it's pair. Then answer should be 5. 2019, the answer should be 5. Let's move to 2018. In 2018, the question is like the number of unpaired electrons present in cobalt 3 plus ion in its ground state. Cobalt 3 plus, cobalt atomic number 27. So when we write the configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d7. This is cobalt atom, but the question is about cobalt 3 plus. 3 plus means what to do? We have to remove 3 electrons. But when you start removing electrons, you should start removing electron from the outermost one. How to identify outermost one? Outermost energy level can be found based on N, principal quantum number. Highest principal quantum number, that is where you find outermost energy level. It is very easy. Doesn't matter however you write the configuration. If you need the outermost energy level, look at N, principal quantum number. Then N equals 4, that's the highest. That should be the outermost energy level, because we write the configuration according to the increase in order of energies, not the distance. Energies of sub-energy level, not the distance. Distance will be given based on a principal quantum number. Then it is cobalt 3 plus. 3 electrons should be removed. We start removing from this, it becomes 4s0. Good. That is not enough. One more. 3d. Then it becomes 3d6. Now they ask the question, if you go back to the number of unpaired electrons, 3d6. You know what to do then? 3d6 we complete like this according to Hund's rule. 1, 2, 3, 4, 5, 6. Then there are how many? 4 unpaired electrons. Where do you find 4? It's in fourth answer. 4 unpaired electrons. In this type of case, it's okay. You can even use the condensed formula, condensed electron configuration. Right? Up to this, then you can replace argon. No worry. Why? Because argon means everything completely filled. Means there is no any unpaired electrons. We can make sure that like that. We can be sure about that. Because argon, noble gas, everything complete, then no unpaired. Then only the unpaired electrons are found in the valence shell, 4s and 3d. So therefore, if you try to answer using that inert gas core, that's also possible here. Let's move to the next question. Next question, 2060. 2060. The set of quantum numbers associated with the last 2 electrons of an atom in an element are. Last 2 electrons, that means about the valence shell they are talking about, right? 300 plus half means what? 300 plus half mean it is 3s electron, 3s, third main energy level is. Other electron also 300 minus half. That's also 3s. There are 2 electrons in the last shell or valence shell. This one electron is in 3s. The other electron is also in 3s. So then what is that? That means there are 2 electrons in 3s. One up, the other down. Means if you go to the last configuration, it's 3s2. 3s2 mean, third period, second group. What is second group, third period element? Magnesium. You can go through the periodic table and identify it. It's then magnesium. What do they ask actually? Yeah, they ask to identify the element. Or the other way, this gives the period number. That is the easier method. Third period. This gives the group number. We have discussed these short methods in the class. We discussed it. Then third period, group 2. That's the point. And then you have the periodic table in MCQ paper. You are given it. So you can find third period, group 2. Then it's magnesium. Or you complete the other 1s2, 2s2, 2p6 and 3s2. Then you see 2, 4, 8, 10. 4 and 6, 10 and 2. It is 12. Atomic number 12. Then which element can have atomic number 12? It's then atomic number. Magnesium. It is then magnesium. So that way also we can identify the answer like magnesium means third answer. Answer third. 2016 answer third. Thereafter, you have 2014 question. The maximum number of electrons having quantum numbers n equals 3, L equals 2. It's very simple. N equals 3, L equals 2 means this is about 3D. Then how many? There are 5 possible ml values. -2, -1, 0, +1, +2. 5 possible ml mean 5 orbital. 5 orbital means 5 into 2, 10 maximum electrons. Then answer is 5. 2014, the answer should be 5. Right, now we have come to 2013 question. These things I'm doing quite fast because I explain those things in detail, these concepts in detail in the class. Next, I explain again those things in the previous discussion. Therefore, through that knowledge, then you can understand these quickly. The number of atomic orbitals possible for which quantum numbers n equals 3, m minus 1. Number of atomic orbitals there. One condition n3, the other condition L is not there, means any value can be up to n minus 1. But ml condition is there. It should be ml, then L, there is a printing mistake. L should be subscript minus 1. Then ml 0, minus 1, 0, plus 1, minus 2, minus 1, 0, plus 1, plus 2. You see, n3 condition there, L condition not there, any value, but ml condition is there, minus 1. Then how many boxes? 2 boxes. Means how many orbitals? 2 orbitals. 2 orbitals can have n3 and ml minus 1. Then answer 2. Uh, 2012. In the case of 2012, the question will be like this. The identify an electron in an atom can be expressed. Okay, then the identity of an electron in an atom can be expressed, blah, blah, given. The question is, identify the set of numbers given will not acceptable. Then, as I discussed in the previous discussion session, there are conditions. For n, it should be starting from 1 to 1, 2, 3, 4, like that. But in the case of L, there is condition from 0 up to n minus 1 maximum. But for ml, the condition from minus L through 0 up to plus L. Then ms, plus half, minus half. That's the simple one. Okay, then what's the problem here? Then first one, 4 to 0. 4 there, 3, 2, 1. 2 is there. N equals 2. Then L 0 and 1 up to n minus 1. Then n equals 3, the value 0, 1, 2. If n equals 4, the value 0, 1, 2, 3. Then look at the first answer, 4, 2 possible. Yeah, 4, 2 possible. 4, 2 possible. But if it is 2, 0 possible? Yes. Because if 4, 2, 2 can have value here from what? Minus 2, minus 1, 0, plus 1, plus 2. This is possible. They say 4 to 0. They say 4 to 0, then 4, 0 is there. Yes. 4 to 0 possible. The second answer, 3, 1, minus 1 possible. 3, 1 possible. Then this can be minus 1, 0, plus 1. Yes, 3, 1, minus 1 possible. No problem. Third one, 3, 2, minus 3 possible. 3, 2. If it is 2, it's minus 2, minus 1, 0, plus 1, plus 2. Between minus 1, plus 1. Then 3, 2, okay. But here, minus 3. Minus 3 is outside of these 5 options. So minus 3 cannot be. Therefore, it is impossible. Third one should be the answer. 4, you can check 2, 1, 1 possible. N equals 2, 1, and this is minus 1, 0, plus 1 possible. 4, 0, 0, 4, 0, then this is definitely yes, possible. For A-level 2012, the answer should be third one. That combination is not possible. Let's move to 2011 quantum number part. Again, they ask the number of subshell orbitals and maximum number of electrons for n equals 3. Then number of subshell is equal to n, means 3. Number of what else then? Orbitals given by n squared means 3 squared 9. And then maximum number of electrons given by 2n squared, then 2 times 3 squared means 80. It should be 3, 9, 18. 3, 9, 18 found in second answer. So yeah, 2011 it's answer 2. 2011, another question is given. Which of the following statement incorrect with regard to the arrangement of electrons among main energy level, sub energy level, orbital. Right. When orbitals of equal energy are available, means degenerate orbital, they first fill singly with electron spins parallel. Yes, that is the Hund's rule. They ask which of the following is incorrect. Second, no two electrons in an atom can have the same four quantum numbers. Of course, it is Pauli exclusion principle. Third, electrons occupy orbitals in such a way as to minimize the energy of atom. Of course, that is actually Aufbau principle. We can say like that. Four, the maximum number of electrons in the main energy level described by the principal quantum number n is equal to n squared. Yes, that's also correct. Then it should be fifth one. The energy of an atom is minimized by filling completely the principal energy level in such a. No, it's not like that. As example, if you fill first 1s2, yes. Then you fill second one 2s2 2pc, still yes. Then you fill third one. Is that correct? 3s2 3p. After 3p, what do you fill? Is that 3d? No. Without filling 3d, you jump to 4s. After completing 4s only, you come back to 3d. Then you see. The energy of an atom is minimized by filling completely the principal energy levels. No, it's not principal energy. First one is okay. After filling that, you go to 2. Then in 2, all everything filled, then it's still okay. Go to P, I mean the third energy level. But in third energy level, it's not like that. From third onwards, it's not like that. Without filling third energy level completely, we move to 4 and come back to third. So therefore, fifth one is the incorrect one. So in 2011, the next question, fifth one. Then 9. 9. A sample of hydrogen atom excited in a flame has electron distributed in n equals 1, 2, 3, 4, 5 energy levels. How many different wavelengths of radiation are emitted by the sample according to Bohr theory? According to Bohr theory. In Bohr theory, did you hear something about sub-energy level in Bohr theory? No. In Bohr theory, they mention only main energy level. There we consider only main energy level. 5, 4, 3, 2, 1. Those are the energy levels. 1, 2, 3, 4, 5. But now they ask what are the possible electron transitions within these? That's what they ask. One possible transition is 2 to 1. The other 3 to 1. Next 4 to 1. Next 5 to 1. Thereafter 3 to 2, 4 to 2, 5 to 2. Thereafter 4 to 3, 5 to 3. Thereafter 5 to 4. Can you see? I mean, can you give me any other electron transition possible? No, everything now completed. Any possible electron transition within these 5 energy levels now completed. Then how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different electron transitions. 10 different energies. Then 10 different frequencies. Then 10 different wavelengths. That's what they asked me. How many different wavelengths are available? So it should be 10. Means answer 4. 2008, which of the following pairs of lines has the difference between them which is equal to that the between third and fourth line of Lyman series of the atomic spectrum? This part, can I use this one and explain it? I think no. For that, I take one more energy level, sixth one. N equals 6. Then in Lyman, it's okay. 4 lines only we represent. No, I'll draw another and then explain. 2008. We are talking about hydrogen emission spectrum. Then let's take. This is first, second, third, fourth, fifth, sixth, and seventh energy levels. Right? Then this is where we have the spectrum. What do we do first? We consider Lyman. That's what they ask. Something about Lyman. Something about Lyman. Hurry. Lyman is the transition from high energy level up to first energy level. The quote, I consider this one, 2 to 1 transition. Then I represent the first line here. That represent energy difference between what? Second energy level to first energy level. Next, 3 to 1. Then that has more energy, more gap, more energy. Then I consider to this side energy increases. Then the other line should be in the left hand side because that line should represent more energy than the previous because gap is large. Okay, then I place it somewhere here. This is that one. Thereafter, 4 to 1, that the gap further increase means energy further increase. Then definitely I should place that line here, left hand side, because energy should be more. But the thing is this one, the gap here should be less than the previous gap. You know why? In the previous discussion also I explained. Because the gap between the first line and second line of Lyman represent energy difference between these two transition, means energy gap between 2 and 3. The gap between the second and third line of Lyman should represent energy difference between these two transitions. What's that energy difference? It's the energy difference between the gap between 3 and 4. 1, 2, 3, and 4. The energy gap between 3 and 4 should be smaller than the energy gap between 2 and 3. That's why this gap between second, third line of Lyman should be smaller than the gap between first and second line of Lyman. That's the thing. Right? Then we have transition from here to here. 3, 4, 4. This is 5. This is 6 and 7. Now the transition from 5 to 1. Then the gap largest means energy highest. Definitely it should be left hand side because left hand side energy increases, but gap further decrease. You know why? Because the gap between these two lines represent energy difference between these two transitions. That energy difference is this one, 4-5 gap. According to both theory, 4-5 should be smaller than 3-4. This is how we have the first 4 lines in Lyman, but this asks about this which is equal to the that between have difference between them which is equal to that between third and fourth line of Lyman. This is number 1. You know, for a given series, we start numbering lines from the lowest energy side. Right? Out of these 4 lines, this lowest thing. This is then second line, this is third line, this is fourth line. Then what does the gap between 3 and 4 represent? Third and fourth. That represent energy difference between these two. What is it? Energy difference between 4 and 5. That's what they ask. Now we move to other series. They ask about Balmer, Paschen. Balmer, first line. You remember that? Up to 2 means transitions from 3 to 2. 3 to 2. Hurry. Then Balmer, second line. It is transition from 4 to 2. I don't draw, then you can understand. Then what could be this gap represent? This gap should represent energy difference between third and fourth. Because the gap the difference between these two transition is the energy gap between third and fourth. If you draw this one, you will understand. Third and fourth. But this is fourth and fifth. This is fourth and fifth, 4, 5. But here, 3, 2, 3, 4, it can't be. Then I go to this one, next 5 to 2. 5 to 2. Then 5 to 2 transition emits more energy. It should be left hand side. But what about the gap? Now gap represent, that gap should be similar to 4 and 5. That's what they asked me, 4 and 5. I can draw this and show you if it is difficult. Then 3 to 2 mean this one. This is first line. 4 to 2 mean this one. This is second line. Right? This is second line. 5 to 2 mean this is third line. Then look at this one. Gap between these two represent the energy difference between these two transition. It is this. Gap between these two lines represent the energy difference between these two transition, means that's our gap. These two gaps same. Then gap between this is then first line, this is second line, this is third line, and there is one more. That gap further decreases like this. This is the fourth line. Right? This is 6-2. But what we need this gap represented by second and third line of Balmer. Second, third line of Balmer means C is correct. Let's see which one is in Pashan. Pashan also then have like this. First line is there, but you know it is transition from 4 to 3 up to 3, 4 to 3. Then second line is there. Then look at this. Second line from 5 to 3. So what does this gap represent? Definitely that gap represent the energy difference between 4, 5. 4, 5 means this one. In the case of Pashan, the gap between first and second should be similar to the gap between 3 and 4 of line 1. That should be equal to the gap between second and third line of Balmer. That's what they asked. Then C correct, second, third Balmer. And Pashan, it should be gap 1 and 2 Pashan. It is B. First and second line of Pashan. But the answer, there are two, B and C. Here the answers are B and C. You know, if you remember that pattern, then B and C mean answer 2. Right, the last question. That's again from 2008. It is a statement question. So what is versus statement? Electrons behave sometime as particle and sometime as waves. What about that statement? Regarding this, what we learn actually, this is also from 2008. What we learn, the de Broglie wavelength, that will give a nice idea. Then de Broglie wavelength is equal H divided by P or MV, momentum. So in that particular case, this side, you know, we talk about wavelength, means it's wave light. That's about particle and wavelength. This is wave property. That is where we discuss lambda. And what about mass and everything? Then definitely it is particle. So both of these two are found together. That means under appropriate condition. Under appropriate conditions, then a particle with a certain velocity should have definitely wave nature also. So in that particular case, it's a particle and it has a certain velocity, then it can act as a wave also. Means both of these two properties are found at the same time. So this says sometimes, so it can't be. I mean, that statement is wrong. First statement wrong because of this. Second statement, you know, electrons have both particle and wave property, of course. Then that's what electron is a particle with a certain speed. That's what de Broglie mentioned. Electrons circulate around the nucleus, should behave as a wave. It behaves as a wave. So that means, yes, that statement true. Electron has a particle and wave nature as well. Then false true, you know, answer the number, it's 4. Number 4. Correct. So in this tute, you have all the questions from 2008 to 2024. Better than definitely you have some free times. Better you find some other past papers questions regarding these sections and test your confidence further. Okay. Like if you go for that. Okay. Right. Then we will meet again under homework sheet 3. So this week, Sunday, I'll give homework sheet 3 for Candy students. And Tuesday, I will give the homework sheet 3 for Pattala student also. So therefore, prepare for that one. Okay, then that's enough. Have a nice day.